Hi, everybody. Just wanted to give you a brief rundown on the proposal involving the Java App Store. First of all, let us consider what's known as the TAM, or Total Addressable Market, for an app store. There are 20 million developers in the world, and 12.3 million of those write desktop apps. Java developers are 6 to 7, maybe 8 million as of 2018, maybe more. When we think about an app store for those developers, each one of them can write tens, if not hundreds, of apps. And when we look at the size in terms of total revenue that Apple generates just from its app store, it's $64 billion, and that's just for the iOS apps. And there's only 2.8 million iOS developers. So logically, the 7.6 million is at least double, 128 billion per year or better, than the iOS developers. And in fact, if there are 6 times more Java developers than there are iOS developers, then you're looking at potentially 6 times the 64 billion. So while this may seem like an absurd number, the total addressable market is $384 billion per year. This is an enormous total addressable market. And so one could make a compelling argument that we won't get that whole market or even a fraction of it. But even a small fraction of such a market is substantial. Now let's take a look at some of the quick prototypes that we've arrived at in the area of the Java App Store, and see how this Java App Store actually works. So here we have the Web Start applications, and this is the so-called Java App Store prototype. Okay, so these are all the apps that we've deployed so far using Java Web Start and the new Java App Store. When we take a look at the value add for the Java App Store, what we really have is a mechanism whereby we sign applications for others. And so what that means is they have to go through a process of validation. We have to know that people are who they say they are using the so-called notary form. And then they get up to 6 submits per year, so these include revisions, for $45, which is an extraordinarily inexpensive way to get signed applications launched. Now, the question becomes, well, what does it mean to have a signed application? And this is a reasonably good question. In the case of deploying applications that have full abilities on a desktop platform, you can see here on a Mac, and this also works equally well under Unix and Windows, what you get is an open Web Start deployment mechanism, which effectively allows you to run your application with full privilege. And here we are running a benchmark that basically shows how many dry stones per second we get. And it runs without complaint. This is a mechanism whereby you can have rich applications. So here's another example of a rich application being deployed using Open Web Start. This application uses what's called Java 3D, which uses OpenGL. That's the Open Graphics Library, and is wrappered by the Java 3D system. And here we see an example. This is a real-time chasing of predators and prey. And what happens eventually when the predators catch the prey is the total number of prey declines. And you can see the decline in the number of prey in here. And so we have little yellow birds that are running away from the big orange birds, and these are considered, big orange birds are considered the predators, and little yellow birds are considered the prey. And they have a small cubic space in which to chase each other down, and they exhibit flocking behavior. And this is something that spontaneously occurs based on the rules of the system that have been pre-programmed into the so-called Boyd's simulation. Let's try another one. This is kind of fun, right? So we get a number of different multimedia aspects to this, which you cannot get without a full-blown desktop experience. So here we have another 3D application, and you can see we're visualizing many spheres. We can zoom in or zoom out and see all the different spheres that are being rendered in real time as I drag around with my mouse here. We'll just zoom in here a little bit and see the interactivity. And this makes interesting patterns which arise from the fact that you have a polar coordinate view of this rectilinear layout of all of these balls in 3D. This is kind of an interesting experiment. We've got some more examples that we can run. Here's an example of a ball just floating on top of a checkerboard. Here's an example of smoke simulation. This is a particle-based system. You can envision how these things can be used for first-person shooter games, and in fact we've had some nice student projects involving first-person shooter games. But you could do other types of games, such as a 3D Tetris if you like. Those are implicit surface examples. Here's an interesting example where the shape can be changed. This is hypocycloid. Just like the kind of thing you might have been able to do with spirograph, only in 3D. Here's a simple torus. The interesting thing about this is you can export your shapes and come up with STL outputs. So I've actually been able to 3D print some of these shapes, which is quite interesting, because you can take shapes that have never been realized and have never existed and then proceed to here's a Mobius strip that's been rotated around, and now you can kind of see how that works. Visualizing these things, you can change the number of facets. Here we're increasing the number of facets for the polynomial and rebuilding it in real time. And you can change sizes and various parameters. Here you can see a mechanism whereby small parameters can be changed in a chain. And this can be stored as a state, and then you can animate between the various states in small increments. And here we get to change the precision with which we move small increments. And this allows you to do an exploration. And then you can proceed to save the state and then animate between various states. This allows you to explore a kind of scientific visualization of an iterative function. Not limited to Java programs, we can use any program that can compile down to the Java bytecodes. In this case, we have Scala being deployed, and this is a time machine utility that Apple has banned from the App Store, but which you can run on your own. Apple banned it for no reason, and they'll ban something for any reason or no reason. And here we're able to effectively deploy an application without a problem. We don't have to worry about Apple. We can deploy it ourselves and we can sign it. And this can run as a first-class application that has access to your time machine and can help you with your backups and view conflicts and settings. So that's my little demo of the Java App Store. I hope you get interested in the project. Thank you for your time.